Hey everyone, day 8 of Advent of Code 2025 today. I will put in my prediction now, I guess. I'll say today's problem is going to be a throwback to a previous year. Admittedly, a bit vague, but I haven't been doing so great so far, so we'll stick to allowing vague things like that. Obviously, there's a little bit of gray area depending on what counts as a throwback. I'm hoping it's a very glaringly obvious throwback though, like boom, lanternfish again, or something like that, where it's super obvious that it connects to a previous ROM. Bam, we somehow use the int code compiler from like 2017 or something. Actually, I don't really want that. The int code problems are somewhat interesting, but I don't know. I actually quite dislike them just because if you ever fell behind, it felt like it was kind of just impossible to do anything. Curious as to your thoughts. I feel like a lot of people really loved him, and I kind of get it if you do like every single day, like in that day. But the issue is like if you're say like a few days behind, and you still want leaderboard ranks, then like let's say you did 1, 2, 3, 4, 5, you missed 6, 7, 8, 9, then like you start day 10 and it's just doomed because you missed like two previous encode days. You are just so unbelievably far behind on your compiler that you just can't do the problem. And obviously, yeah, you can go back and do 6 and then 8 and then 10 or whatever the actual days were. But I mean, then you're not competing for a spot anymore, right? Which I guess doesn't matter now, given there's no leaderboard. But back then, there was a leaderboard, a global leaderboard, and there was no LLMs, so it felt a little more prestigious back then. I don't know. Maybe I'm just being a boomer, yelling at the clouds. This list describes junction boxes, XYZ coordinate. To save the light, connecting pairs as close as possible. By connecting these, now the next two junction boxes are close but aren't already directly connected. Okay, wait. So there are 11 circuits. Yeah. Oh, what is the size of the largest circuits? Okay, cool. So we have a bunch of boxes. Oh, how do I represent this in a meaningful way? I guess I could give them all IDs. Yeah, I kind of like that idea. Okay, so we're gonna have class, what is that again? Boxes? Yeah, junction boxes. So it's gonna have int x, int y, int z, and then int id. Cool. So we have this split, right? Yep, so we're gonna have a list of boxes. And then we're just gonna add to them. Boxes.add. Oh, right, I need to actually get the constructor. Every once in a while I just stumble thinking of if it's this dot x equals x or the other way around. What? Duplicate class box. Oh, did I use this in a previous day? Okay. We're switching to junction box. What? Oh. That's on me. Wow. Cool. Okay. Integer.parse int. My dear friend integer.parse int. So now we have a list of boxes. Now what do we do with these boxes? We need to find the closest pair of boxes that are not already directly connected. Okay. Huh. So how do we do that? I think we just have list pairs, right? No, new class. Yeah, it's unfortunate that, to my knowledge, Java doesn't have innate tuple support. Otherwise, like, I feel like a pair could surely just be a tuple, right? I guess maybe not, because pairs are interchangeable. Yeah, that's a good point. Also, how is distance measured? Is it straight line distance? Euclidean distance is okay. So it's not Manhattan distance or taxi cab distance. I forgot how the equals thing works. So it works like this. Okay, if I don't remember operator precedence. I'm gonna assume that. Actually, I'm just gonna not take any risks. Never quite sure if and comes above or below or. Because the thing is, I feel like there are cases where either makes sense, right? Like where you're doing and, but also or and or. I don't know. It's fine. I will also override hash code just in case. Just something random that clearly is symmetric. Okay, cool. So we have list pair closest. This is a new array list. Alright. So now how do we find the closest 1,000 pairs? I mean, I think we just, wow, this is crazy, huh? Just do a for loop for 1,000. I am a bit concerned about part 2 at this point, given there's 1,000 junction boxes. We can have 1,000,000 pairs. But for now, let's just do naive simulation. So we're gonna do pair equals new equals, we'll have a helper method that's like closest boxes closest. So basically what this one will do is we'll find the closest pair. Given, which pairs already exist. Okay. And then once we find that pair, we will add it to closest. But we will also need to do some applications, like apply pair to the boxes. Cool. And of course we will have a private void apply, which takes a pair, and a list of boxes. Cool. Now once we finish that, we will need to count the number of unique IDs left. So actually, let's just do a set. Right, and then we do for, actually, can I do like IDs dot add all boxes? No, because we'd have to do for box if boxes IDs dot add box dot ID. Cool, and then we return IDs dot size plus that. Cool. Now we just need to do the two helper methods. First one, given a list of boxes and a list of pairs, how do we find the closest pair? Okay, so we start with in long distance. I'm learning slowly, but learning. Max value, right? And then we do for int I equals 0. Just loop through all the boxes. We don't need to double loop through them, so I will just do, and obviously we don't want to include the box itself. So now if, what do we have? Actually, let's just do box1 equals get I, and then box2, because we're gonna have to do a lot of box1 dot xyz. It's just a bit easier if they're not the GIF form. So we have now if we'll do long dist equals box1 dot x minus box2 dot x. Can you do squared like that? Is that a thing? Oh boy, I don't know. I'm just gonna do times itself because I'm worried. Cool. So we have that. Now we just copy this. Box y. This one's all y's, and then this one is all z's. Right, and then we do if dist less than distance. Ah, crap. How do we know? No, we need two forms of ID. We're gonna have ID and immutable ID, because I need to somehow keep track of all of them. I guess I could just do indices. I'll keep the immutable in case I need it though. Return, oh, okay. Actually, yeah, let's just start here. If new pair, actually, yeah, candidate equals new pair, I comma j. If closest dot contains candidate, if it's already in there, we just continue, right? There's no point in doing it again. Otherwise, we actually do want it. If we can't find anything, we'll panic. Not Rust panic, just literally me typing panic. Not ideal, but you know, it is what it is. Yes, good point. I should cast too long. Yeah, I think it doesn't really matter where I do the cast. So I'm just gonna force a cast everywhere. Cool. Alright, so that's closest done. Now I need to do apply. So given a pair, so we have int a equals pair dot a, and then int b equals pair dot b. Right, so now for box b in boxes, no, not box b, we already just used b. If box dot id equal a, box dot id equal b. Cool. Let's not run the timer. Now how the heck are we getting, oh, because I'm not splitting correctly. Split on comma, please. 998. That feels not correct. Mostly because that's not even the goal. The goal is the size of the circuits. Well, we know there's 1,000, so actually I am curious, what are these? So system.out.println box 1. Yes, this is a time waste, but honestly, it's alright. I just don't treat it as seriously anymore with the leaderboard gone. Like, I still try to go fast, don't get me wrong. I think going fast is one of the interesting parts. But, like, making things slightly more readable, slightly easier for me, why not, right? Oh crap, right. We're always just returning this. Let's not do that. We do distance. We do answer equals candidate, and then distance equals dist. I removed the print statement. Right, I should have seen that one coming. Boxes dot get answer dot a. Boxes dot get answer dot b. Okay. Cool. It is looking through 500,000 boxes at each time. Times this, so we're looking at 500 million things. It's kind of impressive it's doing anything, honestly. But the issue is this is not right, right? What we care about is cycle length. So this integer cycles equals new array list. And basically for boxes, cycles dot no, actually let's do a map. Right, because we can then do int id equals box.id, and then if cycles dot contains key id, cycles dot put id comma cycles dot get id plus 1. Otherwise we put cycles dot put just 1. Again, there's some way to do the merge, but it's alright. Alright, cool. Now we just let it run, I suppose. How fast is it? I mean, not too bad, right? We're a 1/6 of the way done. Oh crap, wait, no, this isn't gonna work. I didn't finish the problem here. We need to actually find the largest cycles, right? So, we have boxes, no, cycles dot values dot max, not stream not max. Nope, nope. The issue with this is this only gets us the first value. How do I get the remaining values? Alright, new plan. We have a list. Can we create a list like that? Okay, cool. And then, what is it? Compare. How do you sort a list? Collections, that's what? Yes. Oh boy. I think it sorts descending by default. It will be very obvious if it doesn't. I'm actually just gonna do this. One. Nah. Well. I guess not. Good thing there is a reverse. 16. Well, that's not good. Maybe rather than doing all this nonsense, let's just actually print out what the contents are. 101, 22, 1, 2, 2, 4. No. There should be one that contains 5. Interesting. So I guess first, are we doing the right ones? So we do 1628117, yep, and what was the other one? 425. Okay, so we do connect the right things. Yep. And then we connect 162 and 431. Yep. Then we collect 906, 805. Yep. 431, 425. Yep. Strange. I wonder why this doesn't work. So we take the two pairs. Oh, wait, it's not supposed to be B, right? It's supposed to be... shoot. It's boxes.get pair a.id. And then similarly for B. Let's try that. Nice. Okay. Now we go back. To 1000. Do not want to print that. And now we wait. I really feel like the last part is just going to be run this the whole way through, like all 1 million. Except, wait, at that point everything's connected, so maybe that doesn't make sense. But the problem can definitely get bigger, right? Because there's a million possible connections, or 500,000. Yeah, realistically, this problem could get significantly bigger. Oh, I realized this is going to slow down a lot. Because dot contained is going to get slower and slower and slower. Yeah, I didn't really consider that, huh? Oof. I could have done a set. That would be constant time contained instead of linear time contains. How easy would it be to make closest a set? Where is this used? I think I'm actually kind of close to being done. Oh wait, it's not 5. This needs to still be a list. Okay, well, look, we're 80% of the way there. Yes, we're not actually 80% of the way, but we're getting there. I'm just gonna let it pan out. This has taken quite a while, so it's like, what's an extra couple minutes? But yes, I mean, obviously not smart to let it just run, right? In the meantime, let's start thinking, what could part 2 be? I really wonder if it's just like 100,000 pairs, but like at that point, isn't just like everything connected? Like, is this even an interesting problem at that point? Or maybe it switches to taxi cab distance or something? I don't know. I am honestly not sure what part 2 will be, but I will find out hopefully very soon. No. Where's the number? Okay, what is part 2? You keep connecting until they're all in one large circuit. The first connection causes everything to form a circuit is blank. Okay. So now, let's first see how fast the set-based approach runs. I mean, like 50 times faster, but still pretty slow. That's not great. How do I know? Like, if I run 10,000, right? What is c.get 1? Actually, I should just print c. I'm kind of curious. Alright, 10,000 is actually not that fast. I mean, 1,000 takes a few seconds. This will take probably around a minute. But I'm just curious, like, I mean, obviously, there's at most 500,000 connections, right? I think that part's relatively obvious. I don't know of a great way to easily check at what point everything sort of combines. Hoping this helps. Like, just gives me a sense of scale of like what number size we're working with, right? Now I could pre-compute all the distances. Oh, interesting. So 10,000 is actually too big. Did not realize that. Alright, I mean, let's just do 5. Like, oh, it's almost binary searchable, which is kind of unfortunate. I don't really want to manually binary search, but it's kind of interesting, huh? I'm just trying to think. Oh, 5,000 is actually really, really close. Okay. Look, maybe we kind of just cheese it a little bit. Right? We basically need 3 more applies. right? So basically we can do for like int applies equals 0 while applies less than 3, we run it back. We find a pair, add it, apply. Oh no. But how do I... Okay, let's make this have a boolean. Boolean answer equals boolean changed equals false. If I find something, we do changed equals true, and we return changed. Cool. So then we can do here if apply applies plus plus. Cool. Curious how fast it does after hitting 5,000. If it's pretty fast, that's a good sign. And then we just need to get the actual final pair. It should not be bad. Okay, it pretty much finishes instantly, so that's a good sign. System.out.println boxes.get pair.a plus boxes.get pair.b. Oh, what the heck? That doesn't make much sense now, does it? Shouldn't this, look, apply should only happen if the box ID changes. Oh. If A equal B, return false. Right, because I mean, if they're the same ID, then there's no point in checking over and over again, right? It's just silly to do that, apply over and over and over. Notably, this should be a pretty big speedo because we're not doing every box, which suggests that that is not, in fact, the slowest part, right? Okay, wait. Multiply the x coordinates. Okay, so the x coordinate is... Yeah, x is the first one. So it's this number times this number. That's a chunky boy. Nice. Okay, now I mean a very manual solution. I'm sure there's a lot of ways to clean this up. But you know, it was a fun problem. Not very fast. Yeah, my goodness, I was outside the top 1,000. But it was pretty cool. I like the problem. Let me actually read the description to know if I got the guess right. Ooh, I don't think so. I'm not seeing any obvious references to anything else. Yeah. Okay. I'll consider it a failure. See you guys tomorrow.